All right, we'll try 6 through 10 here, see how we do with that. Okay, so here, that f of x is equal to the absolute value of sine x minus 1/2. And we want to know what the maximum value attained by this function. So let's see. There's a couple different ways to think about this. You could think about it in terms of a graph. You could think about it in terms of the maximum and minimum values that this function takes on. But one way or another, you should get to this answer. And let me just talk you really quickly through the two ways that that it makes sense to me to think about this. One way is to say this. Okay, the sine function itself, as you plug in all sorts of different angles, the sine function forever oscillates between 1 and -1. Right? As you go round and around the unit circle, the y value, which we understand to be the sine function, the y value is forever oscillating between 1 and -1, up to 1, down to -1. So if you imagine those values being plugged in here, when you got up to 1, you'd have 1 minus 1/2, which is 1/2, and the absolute value of that is 1/2. But when you have -1, you'd have -1 minus 1/2, that's -3/2, and the absolute value of that is 3/2. So that's one way to understand it. If you like to think of things a little bit more graphically, then you might try approaching it like this. You might say, well, here's the sine function, and here's the sine function. This is the sine function. What happens when we do the sine function minus 1/2? Well, what used to be 1 and -1 now gets dropped by 1/2. So now we're going -1/2, from 1/2 to -3/2, right? So now we're going like this. And then what happens when we take the absolute value of that? Well, what happens in general when you take the absolute value of a function? Everything that's below the x-axis gets flipped. So now it would look something like, and then this whole thing gets flipped up like that, and so on and so on. So this, what was a minimum down here, gets flipped and becomes positive. So there's your positive 3/2. So one way or another, maximum value is 3/2. Number 7, log base a of 2 to the a is equal to a over 4. Then a equals. I think in this context, it might scandalize you to hear a teacher saying this, but I really think that just trying the values here is possibly the best way to go. In other words, guess and check. It's kind of an unusual, if you will try rewriting this, your instinct, that's a good instinct, I think, with a logarithm problem to say, oh, that means a to the a over 4 is equal to 2 to the a. But I don't really know how far that's going to get you. You're still left with something that's difficult to work with algebraically. So I'm going to go ahead and try these, and we'll have a good little review of logarithms here as we go. So I'm going to try 2. That would be log base 2 of, and then 2 to the 2 squared would be 4, is equal to 2 over 4, which is 1/2. So let's see if that's true. If this was true, that would mean this to this power equals this, and that's not true. That would have to be a 2 over there for that to be true, so that's no good. Let's try 4. That would be log base 4, 2 to the 4th is 16, is equal to 4 over 4, which is 1. That's not true. 4 to the 1st power is 4, not 16, so that's not true. Here we have log base 8 of 2 to the 8th power. 2 to the 8th power is 256. You knew that, right? Is equal to 2, and 8 squared is not equal to 256, so that's also no good. 16, they're getting kind of a little unwieldy here, aren't they? Let's see. We have log base 16 of 2 to the 16th power, I think I might leave it like that, is equal to 4. So is that true? Is 16 to the 4th power equal to 2 to the 16th? Well, that looks like it's got a shot, right? So let's see. It's the same as asking, is 16 to the 4th power equal to 2 to the 16th? And I suppose you could multiply those out, but it might be easier to see if you say, well, 16 is a power of 2. 16 itself is 2 to the 4th equals 2 to the 16th. And of course, you know from Algebra 1 or 2 that in this situation we multiply those. So 2 to the 16th equals 2 to the 16th. That is true. And you can try 32, but that's not going to work. Right. I really can't think of a better algebraic way of approaching that. I think that the guess and check is the way to go there. Number 8. If the solutions of f of x equals 0 are negative 1 and 2, then the solutions of f of x over 2 equals 0 are, all right, well, see, we're talking about what values of x do we have to plug in here to get 0. So this is f of negative 1 is 0, and f of 2 is 0. That's what this says, right? That's where the function, those are the x-intercepts. That's where it crosses the x-axis, where the y value is 0. So now, what about f of x over 2? If we want that to be equal to 0, well, we need this thing inside. X over 2 would have to be equal to negative 1, right? Because we want to plug negative 1 in to get 0. So it would need what's in here to be equal to negative 1, 2. So that's going to give you negative 2 and 4 as answers there. Again, there's a more graphical way of understanding that that I think, if you think about things in those terms, like what do graphs look like, you really get to a very deep level of understanding, I think, of a lot of this stuff. So let's consider that real quick. So if f of x equals 0 for x equals negative 1 and x equals 2. What does that mean? Well, I can't say a whole lot about the function, but I do know that that means those are the zeros, right? Negative 1, 0, and 2, 0 are on the function. Now, what happens, what kind of transformation is it when you do f of x over 2? What happens when you divide by 2 in here? Well, that's like having, when you mess with x's on the inside of a function, that's when sort of the opposite of what you think might happen would happen. Like, for example, if you had the sine function, here's f of x is equal to sine x. If you have that sine function and you sketch it out, it looks something like this. And these intercepts are 0, pi, and 2 pi, right? It has a period of 2 pi. You're very familiar with that function. Now, what does f of x equal sine of x over 2? What is the effect of dividing by 2 in there? Well, the effect is now, again, different ways of thinking about it. But one way of thinking about it is dividing by 2 is like slowing the input down, and that stretches out what it does. So now instead of zero pi and 2 pi, now we have 0, 2 pi, and 4 pi. Right? And notice that's because when you plug 4 pi in here, 4 pi divided by 2, well, that gets you back to like what the original period was, 2 pi. So dividing by 2 in here, your instinct might tell you, or your intuition might tell you, oh, that's going to shrink it by 2. But in fact, it's like slowing things down, and that stretches them out. I say slowing things down in physics. If you're in some kind of physics class, then this axis is often, not always, but often time. So sometimes I just take that for granted, and I think of this as being like time passing. So dividing by 2 is like slowing things down. It takes longer to get to get all the way around the circle or through one period. So in general, that's what happens. Things get expanded. So when we divide by 2 here, instead of -1 and 2, we get stretched out to -2 and 4. Okay. Number 9, if f of g of x is equal to the natural log of x squared plus 4, and f of x is equal to the natural log of x squared, then what's the g function? Well, it looks like the f of g of x, this means take the g function and plug it into the f function. And the f function is the natural log of x squared. So what do you have to plug in here to get it to look like this? Let me talk you through that again. I feel like that was not terribly clear. This is f of g of x, right? F of something, one of these things, is equal to natural log of x squared plus 4. And we know that the f function is natural log of x squared. So which one of these things, when we plug it in for x, will result in this? And again, I think maybe like a guess and check kind of method is the best one. I think it's pretty clear to see that if you took this as the g of x function and plugged it in here, you're not going to get this. You're going to get the natural log of, it's going to be upside down. Likewise, that's not going to get you anything like what we want. This looks like it has a good chance, I think, because here that would be f of g of x would be the natural log of plugging this in for the x squared, and when you square the square root of x squared plus 4, those operations cancel out, and you do in fact get that. So you can try those other ones, but this C is the correct answer. Again, you can see there's a lot of, they're really hammering composite functions in addition to other algebra and graphs and things like that that you should know, but this your comfort level with composite functions is certainly important. All right, number 10. Domain of the function defined by, well, that looks kind of like this last one, is the set of all real numbers x such that, okay, well, let's think about the natural log function. The natural log function is, the domain of that is all real numbers that are greater than 0, not including 0. It looks like this. So we need to make sure here that we're plugging in numbers that are only numbers that are greater than 0, not including 0. In other words, you can only plug into the natural log function numbers that are greater than 0. So if we don't want to have some kind of error or something with our calculator, we need to make sure that this is the case, that x squared minus 4 is greater than 0. And doing a little algebra, that means that x squared has to be greater than 0, greater than 4, adding the 4 to the other side. And you got to think about this for a minute. This does not just give you x is greater than 2, and it doesn't give you x is greater than plus or minus 2 either. You need to think about it a little bit harder and remember from Algebra 2 when you did things like this. This results in x squared being greater than 4. Well, it certainly works when x is greater than 2, but it also works when x is less than negative 2, because when you square negative numbers, they become positive. And for example, negative 3 squared would be positive 9, which is greater than 4. So this is what we're interested in. And which one of these things? So we want the absolute value of x to be greater than 2. Right? Not greater than or equal to, because we can't have zeros in there. All right.